Hello and welcome, friends. So far, we got acquainted with the air pollution, basic sources, their categories, their impacts, the provisions in the law in order to establish the control on them in line with the ambient air quality standards. And we also could know about various hazards that are associated with the air pollution. With this particular module, we are commencing our discussion associated with the meteorological aspects. As we move ahead, we will try to know what are the various meteorological components and how they have their close relationship with the dynamics of the pollutant. So in the first module, let's try to understand the physics of the atmosphere in terms of nature and properties of the components involved in the atmosphere. Initially, we'll just have the brief review of the basic definitions that we discussed about the atmosphere. We'll study about the nature and composition of the atmosphere, pressure, density, and the temperature profile in the atmosphere, and meteorology and its components. So as you learn the contents, you will be able to explain the nature and the composition of the atmosphere, explain pressure, density, and the temperature profile in the atmosphere, and also to define meteorology and state its primary and secondary parameters. These definitions already we have discussed about. So as far as this environment is concerned, it comprises everything that is surrounding us. We discussed it in terms of biotic as well as abiotic components, with the mention of the various spheres as atmosphere, biosphere, lithosphere, hydrosphere. And we know that these are very closely associated with each other in order to sustain the life. This atmosphere is the thick gaseous envelope which is surrounding our globe, and it helps to sustain as well as save the life that is existing in terms of biosphere. The weather was considered to be a particular condition that is existing on a particular place over a short period of the time, whereas after taking into account the existing weather over a close period, so as to know what is the typical pattern that is existing over any period, so that we would be able to say that this is the way the climate is. Hence, the weather patterns are statistically analyzed in order to average out meaningfully the climate. So the climate is long-term pattern of the weather. The meteorology is a science dealing with the atmosphere and its phenomena, and of course it is associated with the weather as well as the climate. We are thinking Earth as a whole along with its associated components. So we wish to discuss about the nature as well as the properties of the matter as well as the dynamics associated with that, and hence we wish to know about the physics of the atmosphere. With the reference of Wisconsin law, we discussed about the definition of the air pollution, and as we are dealing with the outdoor atmosphere, we defined it as presence in the air of one or more contaminants or combinations thereof in such a quantities and of such a durations as may be or tend to be injurious to human, animal, plant life or the property, or which unreasonably interferes with the comfortable enjoyment of the life or property or conduct of business. So as we move ahead, we'll be taking reference of these particular definitions as and when required. That's why once again I try to touch that definitions at the commencement of this particular module. We know that people are producing lot many pollutants through their day-to-day activity. Even nature is producing some pollutants, and ultimately they are traveling through the profile of this particular atmosphere. As they enter into the atmosphere serves as the medium through which the pollutants are traveling in the direction they were originated, as well as they will move in the lateral plane as well as the vertical plane. As they move along, due to their chemical properties, they will be interacting, reacting with the other pollutants that are present in the atmosphere, and accordingly they may get transformed so that they will be getting removed out of the process. Also, as they come together, because of the formation of the bulk, there will be increase in the gravitational settling. They will coalesce, they will impact with each other, and accordingly they will be getting settled. We also know that there is a presence of the mist, there is a presence of the vapor in the atmosphere. Because of the rainfall, because of the fog, because of the snowfall, the particulate and the gaseous pollutants that are entering to the atmosphere will be getting dissolved, and accordingly through the wet deposition process they will be reaching over the surface of the earth. Certain study conducted by Tai et al. In 2017 states that the wet deposition represents for 54 to 71% of the particulate matter having the size range of 1 to 20 micron. As we are trying to study about the interaction of the matter with the energy required for all these particular interactions is provided by the sun. The solar energy is primarily received at the Earth's surface. However, it is redistributed by several other processes. The solar radiations, which are in the form of short waves, are termed as insolation. They will be reaching to the surface and they will be getting reflected back. This reflection is counted in terms of albedo, as well as giving consideration to the Earth as a whole and its position with respect to sun. Various regions will be having different kind of atmosphere as far as incoming solar radiations are concerned. Hence, the angle of incidence would be different. As the Earth receives this short wave insolation, the portion of it will be absorbed, as well as through certain elements it will be transmitted, and even the portion of it will be radiated back in terms of long wave emissions. So, all such interactions are associated with the heat balance, and that governs lot many air pollution phenomena. In addition to the energy interactions, the local wind systems are also quite significant in terms of the transport as well as dispersion of the pollutant. Hence, the energy and motion relationship needs to be taken into account to understand lot many air pollution phenomena which are further causing the weather changes as well as the movement of the pollutants. Whenever we deal with the atmosphere, we deal with air. As we consider the vertical profile of this atmosphere, we can say that there is a lower atmosphere as well as upper atmosphere. This is very general classification, because as we deal with the Earth's surface and as the pollutants are emitted, according to our knowledge, they will be traveling up to certain extent, they will be interacting within certain vertical height, and their fate is decided in certain portion of the atmosphere that is well aware as far as our knowledge is concerned. Such region is termed as lower atmosphere, whereas beyond that what exists is upper atmosphere. So the portion of the troposphere and some lower belt of the stratosphere can be considered to be the lower atmosphere. The troposphere is immediate layer of the atmosphere which is in the close vicinity of the Earth's surface. It is extending about 13 km as an average, with 8 km at poles and 18 kilometers at equators. So most of the human activities, maybe the routine life as well as causing the various emissions take place in this troposphere. This troposphere contains about 85 to 90% of the mass of the Earth's atmosphere. We are much bothered with the activities that are taking place in this troposphere because it has immediate impact as far as our living is concerned. Above this troposphere, the next layer, that is stratosphere, extends up to 50 kilometers of the height. This stratosphere is of our interest because it includes the ozone layer at its lower extent, which absorbs all the ultraviolet radiations that are coming through the insolation and being filtered, they shields our life. Beyond that is mesosphere, which reaches till 80 kilometers of the height. As you see here, the junction of the stratosphere and the mesosphere is called as stratopause. It is at 50 kilometers. This mesosphere is characterized through the occurrence of the meteors as well as the existence of space station, the traveling of the rocket, and hence this is the transitional area between the space where the satellite orbit and the more familiar terrestrial atmosphere that we know. This mesosphere is further characterized with the complex interactions. There is a major turbulence of the wind. The molecular diffusion takes place. It is associated with the photochemistry. It also absorbs the ultraviolet rays, and it is further characterized because of the radiation of infrared rays. This is the zone which may have the lowest temperature as far as the temperature profile is concerned. Beyond that, there is ionosphere as well as thermosphere, which is extended further 80 to 400 kilometers above the mesopause, which could be considered at around 85 kilometers. It consists of the electrically charged particles, ions, and the radio waves which are transmitted from the Earth's surface are reflected from this thermosphere. Beyond that, there is a exosphere, and we do not know much about the characteristics of this exosphere. Even as we consider the mesosphere, it is not accessible through the conventional means like plane, which usually flies at the max height of 25 to 30 kilometers. Also, the balloons cannot reach that particular mesosphere. Hardly they will be reaching around 45 kilometers. And this is too low zone for the satellites. And hence, about the mesosphere also, we do not have very clear picture as far as the various happenings that take place at that layer. So, as we try to discuss on the last slide, most of the atmosphere that we wish to deal with is the troposphere and some lower belt of stratosphere. Hence, with the immediate context, we can consider the atmosphere lying within the 30-kilometer altitude. Also, the presence of the oxygen becomes negligible at the height of 120 kilometers, and hence we human beings may not be interested as far as the living conditions are concerned. The carbon dioxide as well as the water vapor show their presence only up to 90 kilometers, and as we know, the presence of the carbon dioxide is meteorologically important as it is providing the window for the insolation, and also it is opaque for outgoing terrestrial radiation. So the presence of the carbon dioxide is essential in order to create healthy living conditions as far as biosphere is concerned. We also know that the lower portion of that stratosphere acts as a filter and absorbs the ultraviolet rays, and hence such filtration protects the life on the earth. As we consider the various tropics, say the tropical zones in the immediate vicinity of the equator on the northern hemisphere and southern hemisphere, above which there are certain temperate zones or subtropical belts. So these regions are characterized with the higher concentrations of the dust particles due to dry winds in comparison with the equatorial and polar regions. As we concentrate on the composition of this atmosphere, the majority of the atmosphere is associated with the presence of the nitrogen 78.08%. There is an oxygen of around 20.95%. There is an argon with the extent of 0.93%, and the remaining is trace gases like xenon, neon, hydrogen, helium, krypton, and carbon dioxide. Here we discuss about the presence of the carbon dioxide in order to create the healthy condition as far as the biosphere is concerned. With the conception of the earth, as far as the ambient atmosphere is concerned, the carbon dioxide is expected to be 0.038%. As we consider the present scenario, associated with the climate change, scientists suggest that this carbon dioxide has raised to 0.041%. As far as 0.038% and 0.041% is concerned, it appears that there is a very small change. However, even such a small change in this particular presence of the carbon dioxide has caused lot many disastrous things as far as the living conditions to be maintained in association with the Earth's surface. Also, the presence of the water vapor is important because it absorbs the 6 times more radiations as compared to the other elements. So we know about the various layers now: troposphere, stratosphere, mesosphere, thermosphere, ionosphere, exosphere, and accordingly. We know that this troposphere is extending about, say, 10 to 13 kilometers. This stratosphere is extended to around, say, 45-50 kilometers, and accordingly. So, as we consider the geometric altitude, the stratification of various layers change. With these layers, there is a change in the density, pressure, as well as temperature. So, as we consider the geometric altitude, at 0 kilometers, the density of the atmosphere is around 1.1 to 1.2 kg per cubic meter. As we go in the high altitude, this density will go on decreasing. In line with this particular density, the profile of the pressure is also similar. As we consider the troposphere from the ground surface, as we start traveling towards the tropopods, there will be decrease in the temperature. Hence, the warmer air is beneath the cooler air. So, as the warm air is beneath the cooler air, it will always try to travel in altitude, and cool air being more dense, it will try to travel in the downward direction. Hence, there is a continuous movement of this particular warm air and the cold air, which is leading to unstable condition. In view of the air pollution, this condition is very favorable because it is not allowing the buildup of the pollutant. As we consider the presence of the stratosphere as well as even the thermosphere, the ultraviolet rays that are traveling towards the Earth's surface are filtered, absorbed in these two layers, and hence there is an increase in temperature. As we consider the mesosphere, there is a comparatively less presence of the ozone, and hence the temperature is decreasing in this mesosphere. So, the Earth's surface is the major source of heat for the troposphere, though nearly all of the heat comes from the sun. As we have the spatial view of the atmosphere, what you see here is the upper atmosphere. Beyond that is exosphere. In the immediate vicinity of the Earth's surface, there is a troposphere, and above it there is a stratosphere. We know that both are characterized with different densities. Hence, there will be varied refraction of the rays, giving the different colors as viewed from some space station. Over the last few slides, we have been discussing about the various layers, and we also discussed about the meteorology in terms of the science of the dynamics of Earth's atmosphere and associated changes. In order to study the air pollution phenomena, we must understand these dynamics in terms of various parameters, which can be divided into two classes: primary parameters and secondary parameters. So these primary parameters are wind direction and speed, temperature, atmospheric stability, and mixing height. Whereas the secondary parameters are precipitation, humidity, solar radiation, and visibility. As we move ahead, we will discuss about each of these parameters in context of air pollution. So thanks for your attention. I hope the concept that we try to discuss through the physics of atmosphere, the stratification of the layers, the nature of the atmospheric layers interaction with the energy is clear to you. As we move ahead, we will discuss about the first meteorological parameter, that is wind. So bye till then. I wish you very happy learning. Thank you.